In this video, I will discuss the relationship between DFT, that is discrete Fourier transform, and Z transform. Obtain the relationship between DFT and Z transform. Let me consider, let x of n is any discrete sequence if we take the Z transform of this discrete sequence x of n. Z transform of discrete sequence x of n is represented as x of z. So x of z is defined as n is equal to minus infinity to infinity x of n z power minus n. This is the basic definition of Z transform. So now here we know that Z is nothing but a complex plane which is equal to e power j omega. That is, we know that in Z transform, the Z plane, it's an imaginary plane. It consists of a circle of unit radius. We'll assume that the radius of the circle is 1. So it's a complex, therefore we'll assume that this is real axis of z and this is imaginary axis of z. The point from origin to this is 1. We will represent it as r. So here omega is the angular frequency, that is the angular frequency of this is omega. 90 degree, it is nothing but 0 to 2 pi. So now if we sample x of z at n equally spaced points on the unit circle, it means that now if I divide this circle into n points, then the angular frequency at each point, which can be represented as now this w is equal. So it is divided into n points, that is 2 pi divided by n into k, where this k varies from 0, 1 up to n minus 1, because we have divided the circle into n equal points. So each point, that is here we can say that k equal to 0, k equal to 1, k equal to 2, likewise it is divided, k varies from 0 to n minus 1. So now therefore I can represent this z as at each point at each k. So at each k I can represent this omega as omega k. So now I can in turn represent this z as at each k, that is zk is equal to, we have e power j omega. Omega is nothing but omega k, that is j 2 pi by n into k. So now if we consider x of n as causal sequence and we'll assume that it has n samples, that is x of n has n samples, that is 0 to n minus 1. We know that causal sequence means x of n is equal to 0 for n less than 0. So in that case we can represent this x of z as, that is x of z is equal to summation n is equal to 0 to n minus 1, because x of n we have assumed it as causal sequence and it is having only n samples, therefore it is 0, n is equal to 0 to n minus 1 x of n, and here we have z power minus n. Z is nothing but e power j 2 pi by n into k, that is e power j 2 pi by n into k minus n, that is nothing but minus, it is kn. Now let me call it as equation 1. Now also we know that the DFT of same sequence x of n is given by, so that is DFT of same sequence x of n is represented as x of k, which is given by summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi by n into k. Now comparing 1 and 2, we can write that the RHS term is same in both the cases, provided that we have x of k is same as x of z, provided that zk is equal to, we have e power j 2 pi by n into k, that is e power j 2 pi by n into k. So this is the relationship between DFT, that is x of k, and x of z. Thank you for watching.